Good morning, good morning, good morning, good morning, and welcome. I am so sorry about yesterday, but I had no internet, and we did try to run it on a hotspot from my phone, but it was draining so much data and the quality was not good. So we thought the best thing to do was to wait until today and let you know. And I'm really sorry if you were waiting yesterday and then you were disappointed, but I'm really glad to see that lots of you are back today and I recognize your names. So thank you so much for coming today. It's lovely to see you. So hello and welcome to today's lesson. So Rexy's here too. You can just see him at the bottom and he's very busy and ready to hear and ready to listen and ready to think. So remember to make sure you're subscribed. I know I can see that lots of you are. I've got the notification and I hope you've downloaded the Fantastic Kid app because we have been doing some work on that already and we are working hard, like we told you, on the games for all the other year groups. So at the end of our last lesson, which was on Tuesday, we emailed an activity that looked like this. Okay, I've hand drawn it, but you had a sort of computer generated picture, but I've hand drawn it out today. Because on Tuesday I had no Wi-Fi and I've got a wireless printer, so I couldn't print it out either. So I just got on to hand drawn it. So today I'd like to start by looking at that. Can you let me know? Can you give me a thumbs up if you actually did have a go at this activity? Can you give me a thumbs up or a nice emoji to show me if you did have a go at doing this activity when it was sent with the email and we had the link for it in the lesson as well? Can you give me a thumbs up? Can you say, yay, yeah, Miss Nicole, I did, or little ghosty wavy? We've got different sort of things coming in. Okay. Anybody have a go at doing this? Can you let me know? Anybody have a go at doing this? Good morning, and welcome. This was the activity that was sent via email after our last lesson. And I'm just asking if anybody actually had a go at doing this. Did anybody have a go at doing this one? Okay, I'm not having anybody telling me, so that's fine because we can do it now and have a go together. So on our last lesson, we were looking at times tables. We used the counting stick. And we did some counting together. Okay, so we'll do a little bit of that in a moment. But let's look at this today. I'm going to drop the screen down. Okay, so you can have a closer look. And we're going to have a little look at this together. Yeah. Just going to put that in there so that you can see that. Put that in there together. So what we've got here are different ways of talking about multiplication. Okay, so I can see that some of you did have a go at doing that, so well done. So we have got here, we have got the array where you actually see it. You can see what it is. Then we describe the array in words. Then we say how we would write and represent that array as an addition. And then, oh, let's make that look more like a times table sign. That doesn't look very clear, Miss Nicole. And then as a multiplication. So we have got here an array of cookies. And we can think of them in columns. And we can think of them in rows. Now, the way I remember columns are they're the ones that go up and down like columns of a building. So if you had columns of a building holding a building up, if they were lying on the floor, the roof would fall down. So if I had a building like this and it had columns holding it up, the columns are the things that go from top to bottom or bottom to top. They're vertical. They are vertical. So these are the columns. Horizontal is when we are lying flat. Horizontal is when we are lying flat. So we can think of our array in columns and we can think of our array in rows. Columns, vertical lines, they hold the roof on. Rows, horizontal lines, they all go like a row of flowers. They all go along in a horizontal way. So if we are looking at this first array of yummy cookies, there are How many columns? How many columns are there? Show me how many columns there are. How many columns are there in that array? How many columns? Can you show me? Type in how many columns. Hello, welcome people who've just joined. Good morning, good morning, good morning. Well done. Answers coming in already. Oh, you are so ready for thinking today. Fantastic mathematicians. Absolutely amazing. Answers are coming in. Yes, there are 5 columns. 1, 2, 3, 4, 5. How many cookies in each column? How many cookies in each column? How many cookies in each column? Okay, just be trying type your answer in once. Leave space for other people then. I can see them on the page. Okay, so how many cookies in each column? Well done. Somebody's on the ball. 2 people are really on the ball. Well done. 3 people are really on the ball. Excellent. 4 people are on the ball. Brilliant. So we have 5 columns. Remember, I'm writing upside down. And there are 2 cookies in each column. Okay, how many rows do we have? How many rows do we have? And I know sometimes you think, oh, we know this, but this is so important to have this learning really clear. How many rows do we have? Exactly, we have 2 rows. I'm going to use a bit of a thicker pen so you can see clearer. And how many cookies are in each row? How many cookies are in each row? How many cookies are in each row? Okay, 2 rows with how many cookies in each row? There's the 2 rows, 1 row, 2 row. And exactly, well done, good, quick thinkers. We have 5 cookies in each row. So we have 5 columns with 2 cookies in each column, and we have 2 rows with 5 cookies in each row. So as a multiplication, we can say it's either 2 lots of 5 or 5 lots of 2. It still gives us a total of 10. And if we do the adding up, it's 2 plus 2 plus 2 plus 2 plus 2. And oh, actually, these are total, so that was an adding up sign, Miss Nicole. So we can either do 2 plus 2 plus 2 plus 2 plus 2 or 5 plus 5. The answer is still 10. Okay, so let's move on to these. How many columns? These are donuts, by the way. No laughing at my pictures. How many columns are there? How many columns? How many columns? Answers are coming in. Well done. There are 4 columns. How many donuts in each column? How many donuts in each column? 4 columns with 4 columns with how many in each column? Answers coming in with 2. How many rows are there? How many rows? Remember, the rows are the horizontal ones. How many rows? 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 Exactly 2 rows with how many donuts in each row? How many donuts in each row? How many donuts in each row? 4, exactly. Then for me, can you type in the 2 repeated addition sums? I don't want the times table. I want the repeated addition that these show, just like we did up here, the totals. Just like we did up here. What are the totals? Can you do the repeated addition for me? Can you do the repeated addition for me? Yeah, do the repeated addition for me. Okay, just like here, I want the totals, the repeated addition. So what does this show and what does this show in adding up? Well done. We've got so the 2 rows of 4 would be 4 plus 4. And the answer, of course, as you've said, is 8. What would the 4 columns of 2 show? How would you show that? Oh, well done. Oh, well done. Excellent, 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 excellent. Oh, I'm so happy. So happy to be back with you and so happy to see such good maths thinking. Okay, such good maths thinking. So if you have not finished that, if you did not have a go at that, just look back at the last lesson that we did together, and it's in the chat there, but we also sent it to your grown-ups as an attachment for the email. So you could just have a go at the last two. And even if you think, oh, yeah, but I know that, it is very, very helpful to just make sure that you've really got a handle on understanding these. So let's just do one or two more before I give you some problems, just to make sure you've really got a handle on what multiplication is all about. Okay, I think we did some of these last time. We might have done one of them. See it, add it, say it, multiply it. Okay, so here we are seeing it. We are seeing it. So have a little look at what you are seeing. What are you seeing here? Just in your mind, be quite clear. Now show me the addition, show me the add-in equation that goes with what you can see here. Can you write this as an add? So no time signs. Can you write this as an add? Write this as an add. Write this as an add for me, okay? Write it as an add. Okay, let's have a look. Well done. They're coming in. They're coming in. They're coming in. So let me just use this pen that you can see clearly. So we've got 5 plus 5 plus 5 plus 5 plus 5. There are 5 5s there. So if I'm going to write it as an add, there's 1 5. Remember, I'm writing upside down, so please excuse my strange writing. I'm not very well. I wanted to do a little loop there. I'm not very well practiced at writing upside down. 1 2 3 4 5. So 5 plus 5 plus 5 plus 5, 5, 10, 15, 20, 25. Yep, people have got the answers in. 25, okay? So that's an add-in. Now we're going to say it. There are how many equal groups? How many equal groups are there? There's 1 group, there's 2 groups, there's 3 groups, there's 4 groups, there's 5 groups. So there are 5 equal groups. 5 equal groups. With how many in each group? Well, there's 1, 2, 3, 4, 5 in each group. This one has the same number of groups that are in them. And we know there are 25 all together. There are 25 all together. Yeah? Now, write me the multiplication, please. Can you write me the multiplication now? So now use the sign. Now use the sign, please. Now use the sign. Okay. Now use the sign and show me the multiplication. Okay, I can see them coming in. I can see them coming in. Yep. So absolutely. 5 times. Well, remember I'm upside down. Ooh, finish that off. Oh, look at that. That doesn't look very clear. Now it looks like a star. Okay, I'm going to do that underneath. I must practice writing upside down. Okay, but I know it's so much clearer for you if it's down there. Okay, so we see it. We add it. We say it so that we are clear. There are 5 equal groups, and each of those groups has 5 in it, which makes 25. If I write it as a multiplication equation, it's 5 lots of 5. But that means the same as this. 5 added up 5 times. That means the same as this. That means that there are 5 groups, each with 5 in them, and altogether that is 25. Okay, altogether that is 25. So let's do this one for me, please. Let's do this one for me. So go straight to the add-in, please. Have a look at what's here. This, you're seeing it, and show me the adding up. You're seeing it. Now do the adding up for me. Okay, can you do the adding up for me? Okay, so you're seeing it. Can you do the adding up for me? Let me see those adding ups coming in. Now I want the expanded adding up. So how many is in each group, and add them up that many times. Okay. So, well, I can see what you've done there. 40 plus 10 is 50. Absolutely. You've put these, but I really want to make sure you understand that this is 10 plus 10 plus 10 plus 10. Count how many there are. 1, 2, 3, 4, 5. Exactly. Exactly. So we have got 1, 2, 3, 4, 5. Lots of 2, 4, 6, 8, 10. So we have got 10 plus 10 plus 10 plus 10 plus 10 equals, running out of room there, equals 50. Okay, so let's say it. There are how many groups? There are 5 groups with 10 in each group. There are 50 altogether. Now write the multiplication for me, please. Can you now write the multiplication for me? There it is. We've seen it. We've shown it as an add, repeated addition. Okay, specifically a repeated addition here. Then we have told it. We have said it. Now multiply it for me, please. Now multiply it. Now, multiplication is commutative, just like addition, which means it doesn't matter which way round you're doing it. But I've asked you to show me what is here. And we don't have 10 fives, although the total would be exactly the same. That is not what's shown there. So can you just be careful about that? So what we've actually got is 5 lots of 10. Okay. And although 10 lots of 5 comes to 50, when it comes to sharing, sometimes it can be a bit confusing if you don't think about the groups. Okay. Some people get a bit confused then. So we have got 5 lots of 10. 10 added up 5 times. There are 5 equal groups with 10 in each group. 5 times 10. And I know it's commutative. I know, just like addition, doesn't matter which number you put in front. For multiplication, will still give you the answer because you still got those same quantities. What you're doing is finding out how many altogether, just like in maths. It doesn't work with sharing. It doesn't work with taking away, because it does matter which order they go in. Okay, well done. Now let's get some brains working. Let's get some problems going. So let me get my little piece of cover-up paper so we can look at one at a time. Okay, let's have a look at Amina's problem. Let's have a look at Amina's problem. So Amina runs 10 meters 7 times. Write the multiplication sum equation and solve it. What multiplication equation would you need to write to solve that problem and solve it, please? So Amina runs 10 meters 7 times. So can you show me the multiplication? Don't just give me the answer. Okay, so she's running 10 meters 7 times. You know, it doesn't matter which way around you're going, but it is 7 lots of 10, isn't it? Okay, because, yeah, that's it. She runs that, and you've got the answer is 70. So you could say it's that, or you could say she runs 7 lots of 10, would still give you the answer. It is a measure equation. So what are you all missing from the end of your equation? What are you all missing from the end of your equation to make it finished correctly? What are you all missing? What do you need to put on the end? What do you need to put on the end? Hello? What do you need to put on the end? She ran 70 meters. So remember, well done, well done. Somebody got that in, fantastic. Remember your units, okay? When you're solving equations, you need to think about the real context of the problem that you are solving. So well done. Let's have a look at our next little problem. Okay, let's have a look at our next little problem. I'm just going to cover up so you're just focusing on the next problem. Let's have a little look. I've got it written down here. Yeah, Rex is watching as well. So apples come in bags of 10. There are 83 children. How many bags do we need to give each child an apple? How many bags of apples will we need so that every child gets an apple? There are 83 children, and the apples come in bags of 10. So how many bags will we need so that each child gets an apple? And how many spare apples will we have left? So can you say, so many bags with so many left? So many bags with so many left. Okay, let's have a little look. How many bags will we need? Apples come in bags of 10. There are 83 children, and all those children want an apple. So how many bags? Not how many apples, how many bags? Listen to the problem. How many bags do we need to give every child an apple so that every child gets an apple? How many bags? How many bags? How many bags? Oh, well done. Very clear. 8 with 3 left over. Somebody's written exactly what was asked for. So how many bags? So let's just put up here. Think about what I have asked you to do. Okay. So this is the one we're looking at. So there are apples come in bags of 10, 83 children. How many bags with how many left over? 83 children, so multiples of 10. If we had 8 bags, we wouldn't have enough. That would be 80 children. So we actually need 9 bags. There are 83 children. 9 bags. Apples come in bags of 10. There are 83 children. So we need 9 bags. If we only had 8 bags, then 3 children would not have an apple. There are 83 children. 83 children. And apples come in bags of 10. So we need 9 bags. Then we will have 90 apples. That will be enough for 83 children. How many will we have left over then? I have not seen the correct answer yet. 9 bags with how many left over? Now I've helped you with this bit. So 9 bags would give us 90 apples. There are 83 children. So how many would we have left over? Think about bonds to 10. 83 children, 90 apples. Well done. I've just seen the right answer come in. I've just seen the right answer come in, and I've just seen it again. Thank you very much. 7 left over because 90 take away 83. Let's just count on. There's 83. There's 90. How many jumps do I have to do to get to 90? Well, we know 3 and 7 is 10. That's going to take us to the next 10. So I'm going to actually have to add on 7. So 83 children, 90 apples, leaves us 7 left over. So 9 bags with 7 left over. Now that question seemed to catch you out a little bit. People saw the 83 and went, oh, 8 bags. But actually there were more than 80 children, weren't there? 8 bags would have been okay if there were 80 children, but there were 83 children. Okay, there were 83 children. So just focus on the problem. Make sure that you have read the problem very, very carefully. So we've got a Rexy problem next. We've got a Rexy problem next. Okay, so as we know, doggies like biscuits. Doggy biscuits. Okay, doggy biscuits. Now, Rexy is allowed 5 doggy biscuits a day. How many biscuits will we need for 2 weeks? How many biscuits will we need for 2 weeks? If Rexy is allowed 5 doggy biscuits a day, how many biscuits will we need for 2 weeks? How many biscuits will we need for 2 weeks? That's the first one. How many biscuits will we need for 2 weeks? Okay, so he is allowed 5 doggy biscuits a day. How many biscuits will we need for 2 weeks? Think about what you've got to sort of think about there. Well done. People are thinking, how many days in a week? Well, how many is that for 1 week? And then double it. Okay, let's just open that up and have a little look together. Got some answers coming in. Yep, so well done. So he's allowed 5 biscuits a day. There's the 5. There are 7 days in a week. So for 1 week, 7 5s. Come on, 5, 10, 15, 20, 25, 30, 35. So that's 35, but that's just 1 week. So 35 plus 35, well, I'm going to do 30 plus 30 and 5 plus 5. 30 plus 30 is 60. 5 plus 5 is 10. 60 and 10 is 70. So to give Rexy 5 biscuits a day for 2 weeks, I have to have 70 biscuits. Okay, so have a little look. People who put 35, that's just for 1 week, isn't it? Unless you were just answering that question there. So that's how I did it. I said, well, 1 week would be 35. So 2 weeks is 35 and 35. And I split my 10s, I split my 1s, and then I added those together. Some people might just know double 35 is 70, in which case you don't need to do all of that. The next part of the question says, Rexy's biscuits come in boxes of 100. Will we have enough biscuits for the next week as well? So we've done 2 weeks and we've used 70. The biscuits come in boxes of 100. So are we going to have enough biscuits for the next week? If you say yes, explain why. If you say no, explain why. Okay. Are we going to have enough biscuits for the next week? So he has 35. That's 1 week is 35. That's how many need for 1 week. That's how many we need for 2 weeks. What about next week? For week 3. Will we have enough in that box of 100? Will we have enough in that box of 100? Some people say yes. Will we have enough? Okay, just look at what we did here. Person who said 60, you forgot to add the ones together. So it takes 70 for 2 weeks. Can we add another 35 to 70 and the box of 100 will be enough? So 70. If we add another 35 to 70, let's have a look. There's 70. And your next week is going to take another 35 biscuits. Okay, so we're over here. So let's add our 10s together. 70 plus 30 equals 100. Oh, okay. But we've got the 5 as well. 100 plus 5 is 105. So if the answer is 105 for 3 weeks, there we are. There's the answer. 3 weeks, you need 105 biscuits. And the biscuits come in boxes of 100. Will we have enough biscuits for 3 weeks? No. We will have to get another box of biscuits because that will not be enough. Okay. One more problem. Have a look at this guitar problem. See if you can work this out. Have a look at this guitar problem. I am saving for a new guitar, which will cost £150. That new guitar will cost £150. I already have £40. I get £5 pocket money a week. When will I have enough money? How many weeks' time? How many more weeks do I have to save up before I will have enough money? Now, these are 2 3-step problems. You've got to really think about what is the question asking you. I'm saving for a new guitar. Saving for a new guitar. So let's have a think. I've got £40 already. I've got £40 already. So I need to take £40 away from 150. Well, I know 50 take away 40 is 10. So I'm now needing to have £110 because I've already got the 40. So I'm now needing to have £110. I get £5 pocket money a week. So how many weeks is it going to take me to save £110? How many fives do I have to count until I get to 110? Now I know in my head that there are 25s in 100. I know because 10 fives are 50, so 25s are 100. So I would use that maths already. I know that 10 times 5 equals 50. So 20 times 5 must be 100. So that's 20 weeks, but I've got to get to 110. So how many more weeks do I need to get to 110? 20 weeks will get me to £100, but I've got to get to 110. Now 10, how many fives is 10? See if you can do the answer with those clues. I already have £40, so I can take £40 from 150, and that leaves me with 110. Now I use the maths that I know already. I know 10 fives are 50. So 25s must be 100. 25s must be 100. So I know it's 20 weeks to get to £100. So how many weeks is it to get to 110? How many weeks do I need to have saved £5 a week to get to £110? If 20 weeks will get me to £100, how many weeks to get me to £110? Now, I have not seen the answer come in yet. I have not seen the answer come in. 20 weeks will get me to £100. Oh, here it comes. How many more weeks? Think about how many more fives do I need to go from 100 to 110? Now, I know that 2 fives are 10. I've already got 20 weeks. 2 more weeks will get me to £110. So 20 and 2, 22 weeks. In 22 weeks, I will have enough money. Now let's just go through that again. I have to save up to 150. I've already got £40, so I can take 40 off there. I know that 40 taken away from 50 leaves 10. So 40 taken away from 150 will leave me with £110. I know that 10 fives are 50. So if I double that, 20 fives, I double that is 100. I'm not quite there. I have to get to 110. Well, all I have to do is those £10, another 2 fives. So 20 and 2 is 22. So 22 weeks. When will I have enough money? In 22 weeks' time. In 22 weeks' time. Wow, that was a big brain work. I think my brain hurts. I can feel your brains going woo, all the way through the internet. Okay, let's have a look at now how we can use those ideas of tables to help us answer some more questions. I've got another question here about baking bread. Okay, I've drawn it out for you so you can see it, so that you can see it. Let's have a little look. Okay. There. Can you see my question? Just move it a little bit. Okay. I am baking bread rolls. There they are. Ooh, don't they look yummy? I bake in groups of 10. There they are. Groups of 10. How many bakes have I completed? How many bakes have I done so far? So I'm baking batches of 10. How many bakes have I done so far? How many bakes have I done so far? Okay, listen to the question. I didn't ask you how many bread rolls there were. How many bakes? This is what we're doing now. We're really trying. Well done. We're trying to listen to the question and use our maths to understand what we're being asked. I am baking in bread rolls. I bake in groups of 10. The question is, how many bakes? Not how many bread rolls there are. How many bakes have I done so far? Well, I bake in groups of 10. So there's 1 bake. There's 2 bakes. There's 3 bakes. I have done 3 bakes so far. So well done, those children who said 3 bakes so far. Listen carefully to the question. 3 bakes. How many more bakes do I need to do to have 50 bread rolls? How many more bakes? Not how many more bread rolls. How many bakes? How many more bakes do I need to do so that I have 50? I've done 3 bakes and I've got 30. I want to have 50. How many more bakes do I need to do? How many more bakes? How many more bakes do I need to do? How many more bakes do I need to do? Well done. Okay, so that 3 bakes give me 30. If I want to get to 50, I need to do another 2 bakes. If I want to get to 50, I need to do another 2 bakes. Yeah, that's what I need to do. Another 2 bakes. So let's just have a little look at arrays again and see if you can write both of the equations for me. So I've got an array here that I'm showing you. Okay, I think we've done enough on addition now, so I'm going to cover that bit up because you all seem to be very confident on that. But I want you to write the 2 different multiplications that this array is showing. What are the 2 different multiplication equations that this array of beautiful plums is showing? Think about columns and think about rows. Can you show the 2 different multiplication equations that this array is showing? Okay. What are the 2 different multiplication equations that that array is showing? I'm writing them here. Okay, so I've seen one of them. I want both of them, please. I want both of them. Okay, if you can try and get in the habit of writing them both before you press enter. Equals and. Okay, so let's have a look. When I look at the rows, 1, 2, 3, I have 4 rows of 1, 2, 3. I have 4 rows of 3, so 4 times 3. When I look at the columns, 1, 2, 3, I have 3 columns of 1, 2, 3, 4. 3 columns of 4. So the 2 different multiplication equations I can write for that array are either 3 lots of 4 or 4 lots of 3. It doesn't change the fact that there are 12 plums. It does not change the fact that there are 12 plums. Now give me a thumbs up if you got both of those. Okay, did you get both of them? Just say yes or a thumbs up. Yeah. Either 3 times 4 or 4 times 3. It is the same answer. We can just arrange them in different ways. We are not taking anything away. We are not adding them. We are just arranging them in different groups. We are just arranging them in different groups. Okay. So just before we finish, and we haven't really gone on to sharing very much, but we certainly will next week. But I just wanted to make sure we were really understanding these groups, because if we can understand the groups and see how our tables help us, sharing becomes so much easier. So we have an array called A, we have an array called B, and we have an array called C. Could you please match the multiplication equation to each array? So which one goes with A? Which one of these multiplication equations matches to A? Which one is A? Which one is A? Which of these shows A? Which one shows A? Which of these multiplication equations shows A? Okay, which of these? Choose which one shows A. Oh, you can't see the bottom one. Let me have a little look. That's not very helpful. Wonder answers have not come in. Can you see it now? You still need a little bit more, don't you? There we go. There we go. Which one shows A? Which of these multiplication equations show A? Helps when you can see it, doesn't it? Yes, Miss Nicole, it does. Okay, which of those? Now you can see it, of course. You are very clever, and you have told me. Yeah, so A is represented by this equation. 3 lots of 2. There they are. 1, 2, 3 lots of 2. So this has gone by the rows. 3 lots of 2. So we can link this one down here. So which equation represents B and C? Can you put B and then type the equation and C and type the equation? Can you do that for me? So put B, and I'm not going to tell you which one it is, and C. Okay, so can you just type those in for me like this so I can see that you can see B and C? What about B and C? Can you show me B and C? Which one shows B and which one shows C? I'll put that down there because we've used that one. So we know that one is not going to be used there. So can you show me which one is B? So put B and then use a colon. Okay. Yep, well done. Thank you. Well done. Good listening. That you actually put the 2 equations before you put enter. Yeah. Let me have a little look. So let's have a look what B is showing. So I have 2 groups, and each group has 5. 2 lots of 5. So obviously you're going to come over to here. And C, I have 1, 2, 3, 4 groups, and each group has 3 in it. So C is coming up to here. Okay. A, B, and C. Okay. A, B, and C. Let me take that away now so that you can see it clearly. Okay. So we've matched some groupings, done quite a lot of work today on groupings and matching them to the multiplication equation. What I'd like you to think about as well is how could you link the sharing equation as well. That's what we're going to start off with next week. That's what we're going to start off with next week. Looking at the sharing equation, it's really important that we are clear on those groupings, okay? So thank you for joining, Rexy and I. Thank you so much for coming today, even though we were supposed to be yesterday. So thank you so much for coming back today. I keep forgetting to say, well done, well done, well done, well done. Let me just turn this little light off and you'll be able to see this better. Okay. Can you see it flashing? Can you see it flashing saying, well done, well done? Excellent, students. Thank you, chickadees. Lovely to see you today. Okay. Keep coming back. Keep joining us in our online lesson. It's been really lovely to see you today. Lovely to see some new friends and some of our old friends who've been with us right from the start. Please get your grown-ups to share the lessons. We will be back next Tuesday. Hopefully, internet not letting us down. Brilliant. Have a good day, and I will see you next week. Bye-bye, chickadees.